So in the last lesson, and in the first couple of lessons, we've been dealing with the subject of trig. And in grade 10, trig is really all about this acronym called SOHCAHTOA. And what it allows us to do is to find unknown sides or unknown angles in right-angled triangles. But then all of a sudden in grade 11, we start to deal with stuff like the sine of 210 or the cos of 330. And this is a little bit odd because if you think of right-angled triangles being based, or if you think of trig being based on right-angled triangles, how do you have a triangle with an angle of something as big as that? And the way we get around that is we actually put our angles on the Cartesian plane. And so the 210 would look like that. It gets to 180 and then it goes a little bit further. And then we draw a triangle using that angle of 210. But really the only angle that matters is this little bit over here. And since we know that was 180, this bit over here is 30. And the same thing goes for 330. If we imagine 330 being all the way around to here, sorry, that's not the best drawing, we construct a triangle. Now, the only thing that's left, if this is 330 the whole way around, the only thing this can be over here is 30, because that's how I would get up to 360. And so this is how we connect triangles to angles that are really, really big. And then what's more is we said there is predictability in terms of where different trig ratios are positive or negative. So we spoke about quadrant 1, quadrant 2, quadrant 3, quadrant 4. And if something was in quadrant 1, it was positive. So we know like the sine of 30, the cos of 30, the tan of 30 are all positive because they're in quadrant 1. But once we get to the other quadrants, it changes depending on what ratio you have. So the way we got around this is we have what's called the cast diagram, and that tells me that the sine of 210 will be negative because it's in quadrant 3. So in quadrant 3, only tan is positive. And then the cos of 330, well, if I use this diagram, the 330 is in quadrant 4, we know cos is positive, so we know that that would be positive in that quadrant, and then this one would have been negative. Give me a thumbs up if that sounds familiar to you, if that looks good and you feel like I've seen that before. Now, what we also did was we said that we can rewrite these bigger things in terms of angle formulas for the quadrants. So if an angle is in quadrant 1, it'll have the form theta. If it's in quadrant 2, it'll be 180 minus theta. Let me get rid of all the other bits and pieces. If it's in quadrant 3, it will be 180 plus theta. And if it's in quadrant 4, it will be 360 minus theta. And what this allows us to do is to get at that little bit in the triangle that's so important. And so what we do to reduce, or what we call the reduction formula, is we take the sine of 210 and we rewrite it as the sine of 180 plus 30. And you'll notice, if you haven't already, that 210 is in quadrant 3, so that's why it's got the 180 plus 30. And then to reduce this, all we say is sine positive or negative in this quadrant? It's negative. And then we say, what is the ratio? And then we say, what is the little bit in the triangle? It's just 30, so minus 30. So minus sine 30 is the reduced trig ratio of sine of 210. And for the cos of 330, we do a similar thing. We say, look, in quadrant 4, I would rewrite this as 360 minus 30. That's the format of quadrant 4. And then we say, well, in quadrant 4, cos is positive, and then I keep this ratio the same, and then what's the little bit in the triangle? It's that. And that is called the reduction formula, which we did in the last lesson. Again, give me in a score out of 10 with the reduction formula, how are you feeling? Where 10 is like easy, where 0 is I have no clue. Let me know how you are doing on that reduction formula thing. Give a score out of 10 in terms of understanding it. Okay, fantastic. Then I know I can move a bit faster if we feel comfortable. Okay, now the next type of reduction formula questions, they don't have angles in them. They just have like just an angle already. It's almost like they're easier. And the way this works, I'll do number one with you, is you say, look, what quadrant is 1n? And it's going to be in quadrant 2 because it's 180 minus theta. Well, if I want to reduce this, is sign positive or negative in this quadrant? In quadrant 2, it's positive. And then we say, how far away is this angle in total from the nearest horizontal? Now, the nearest horizontal is 180. So it is just theta away from the nearest horizontal. So it would be this bit over here. So we write the sine of 180 minus theta as just the sine of theta. And that's applying the same idea that we did before, except it doesn't have numbers, it has variables. I want you all to do numbers 2 to 5 by yourself. And then if you're unsure, I would like you to raise your hand and ask a question. If not, just tell me if you can do these, just say 2 done, 3 done, 4 done, and so on. And then I'll know in the chat that you've done them, and then I'll give you the answers. But for the rest of us, I want us all to try and do number 2, number 3, number 4, number 5. And when I say do them, I want you to reduce them from big trig angles to smaller ones. So off you go, and I'm going to grab some water. Okay. And if you need, I'll even leave the example up there for you to see what is going on. I'll be back in a moment. I just want to get some water. So in the chat, just tell me, like, you can even say done, and then you can say 2, 3, 4, 5 if you've done them all, or tell me how many you've done, just so I have some awareness of how many you've done as you go. So quadrant 2, let's have a look. So 180 minus theta must be in quadrant 2, and in quadrant 2, cos is negative, so this will be negative, but it must stay the same. So negative cos theta. Okay, so this one over here is going to be plus cos theta for number 3. Number 4, now that goes the whole way around, but then it gets into the quadrant 1 again. So that stays the cos of theta. And then the last one, number 5, well, 180 minus theta, that's quadrant 2, but tan is negative, so that's minus tan theta. Okay, so this is the reduction formula applied to simple questions, but I can see that you guys, I think, are fine with this, so I'm going to move on. And the next type of question takes the reduction formula. Oh, please do number 6. It's about, actually, number 6 is a bit of a misprint. Number 6 is exactly the same as number 4. And so it's also going to be cos of theta. Okay, so now in the next part of this lesson, we are going to use something called special triangles. And I just want to give you a quick summary of what special triangles are. Special triangles are known triangles that we use to evaluate trig ratios. And the question will often say you are not allowed to use your calculator. So that is the one special triangle, and this is the other. This special triangle actually comes from chopping a square in half. Like if you imagine a 1 by 1 square and you chopped it in half, or you chopped it this way, you would get, okay, that's not a very good drawing, but basically that's what you would do. And then this one over here comes from chopping an equilateral triangle in half. But all you need to do is memorize these triangles. And so 45, that's going to be a 1, that's going to be a 1, that's going to be a root 2. And then for this special triangle, this is going to be a 1, a 2, and a root 3. Give me a thumbs up if you have seen these special triangles before. So you've seen them in class. Give me a thumbs down if you've never seen them. I need to know how many of you have at least seen them and how many of you have never seen them, because it's different depending on what. Okay. So what these allow you to do is they allow you to evaluate something like the cos of 45 or the sine of 60 without using a calculator. And let me show you how. So you know that cos is a over h or x over r, and you know the sine of 60 is o over h. So all you do is you go to the triangle and go, okay, well, 45 clearly goes with that triangle, and you say, let's say you choose that as your reference angle. That would be O, that would be A, that would be H. So the cos of 45 would just be A over H, or 1 over root 2. And then the sine of 60, well, here's 60, so that would be O, that would be H, that would be A. The sine of 60 must be root 3 over 2. And so that's how we can evaluate this without using a calculator. We just use, but you need to memorize these triangles. Give me a score out of 10 about understanding evaluating special triangles. So if you know how to evaluate, if I said to you, what is the tan of 45? Could you do that quickly and easily? Give yourself a score out of 10 for how well you know how to evaluate the tan of 45. So the tan of 45 should be 1 over 1, or O over A. So all I did was I went to this triangle and I went O over A is tan, so it's 1 over 1. Okay, now how can I upgrade this? Well, what I can also do is say to you, can you evaluate the tan? In fact, let's do this one. Let's go, can you evaluate without a calculator? What is the sine of 150? And I want everyone to try and do that by yourself. If you're feeling generous, you can put a tip in the chat about how to do it. But can you evaluate the sine of 150 without a calculator? And see if you can use what we've learned so far in today's lesson. Simtanda, do you want to give us a tip as to how you got to your answer? What was your journey about? What did you have to do first? Yeah, Simtanda, let us know what you did.
So first I put it in the other form that sine 150 could be, it's going to be sine 180 plus minus 80 minus 80.
Okay.
When sine is positive in the second quadrant, it's going to be sine 30.
Okay.
Then you go to a special angle, and as you can see, sine 30 is equals to 1 over 2.
So here's my O, and here's my H. And so you're right, we get 1 over 2. So Siamtanda, I completely agree with you. That's what I would get to. So the sine of 30 is a half. There's two steps. There's the reduction step, and then there's the substitution step from the triangle. So Atlikang, yes, that's exactly what you have to do. You have to reduce it first, because your special triangles don't have 150. They only have what's called acute angles, and so you need to reduce it first. Okay, now let me show you. That was just a little thing example. I want you to take a minute or so and try and work out which of these three you have to evaluate, or it says find the exact value of the cos of 240 and then choose which of the four options you think are correct. So I want you to try and do that using what I just showed you in the previous example. Step 1, reduction. Step 2, special triangle, but you have to write down the special triangle for yourself. And so over to you guys, and we'll wait for the answers to appear. But yeah, take a moment to just think about what we were doing. Off we go. Hmm. Okay, so there are many students saying C, so I'm going to try and see if I agree. So in quadrant 3, oh, you know why? Because it's a negative. I understand why you knew it was C. So quadrant 3, cos needs to be negative. So this is minus cos 60. And because you can see there's only one with a minus, it had to be C. But just to show you how you would get a value is you would need this triangle. And then because 60 was the reference angle, this would be O, this would be A, that would be H. And we know that the cos of 60 is just A of H. So it's, and the minus is there. So the answer is C. So that's actually getting pretty good. So I'm happy with that. Let's go with this one. Which acute angle has the same tangent as 220? Another way of saying that is what angle X is equal to the tan of 220? You know, what angle over there, what is this X over here is another way of saying that question. And what do we think the answer for this is? So I suppose 220 is in this quadrant. So we know that tan is positive. So that's good news. And also angles in this quadrant are 180 plus theta. So we get the tan of 180 plus 40. But that means that if I was reducing this, I know it would be positive, I know it would be tan, and I know it would be 40. Because if you think about it, it's 180 to get here, and this last little bit is just the 40 that gets me to 220. And then that's the triangle that we use to evaluate 220. So the answer is A. The answer is A. Okay. So now what happens is in tests and exams, we don't always do them by themselves. We tend to string them together. And so what I want us to do is before we have our break, which is about 2 or 3 minutes away, we are going to determine the following without the use of a calculator. And you are just going to do for me number 1. Now, I'll give you this hint. The sine of 30 doesn't need to be changed because it's already an acute angle. But the tan of 150 and the cos of 330, they need to be evaluated. And we're not allowed to use a calculator. So I will give you the triangles because I know that you're still learning them, but I want you to do everything else by yourself and then tell me when you're in the chat when you're done. I will then come along and see if we've got the right answer. But for now, I would like you to try and do the green one by yourself. Good luck. May the force be with you. Oh, I'm telling lies. It's not plus. It is minus for tan 30 because this is in quadrant number 2. But cos is positive because it's in quadrant number 4. I could even say quadrant 4 like with a Roman numeral, whereas this is quadrant number 2, and we know that tan is positive there. But now we still have to evaluate all this stuff without a calculator. See what you can do. And just say done in the chat when you're done. So tan of 30, that would be O, and that would be A. So 1 over root 3 is that bit. And the sine of 30 is 1 over 2. Oh, I actually don't need the 45 triangle because there's no 30 or, I mean, there's no 45s. Cos of 30 is going to be root 3 over 2. Now, this last bit, okay, give me a thumbs up if you got all this stuff. Give me a thumbs up if you got to that point. Okay. Now, this last bit, in order to bring all these things together, you have to be a little bit sneaky. So I'm going to show you how to do it. You obviously can do it with your calculator, but it does say the question without a calculator. So the biggest problem when you have two fractions you're adding is if your denominators are not the same. And so because this one has 2 times root 3 as the denominator, what I'm going to do is I'm just going to multiply the top and bottom by root 3. And what that means is that actually I have minus 1 over 2 root 3 plus 2 root 3 on the bottom because I've just changed the order. Now root 3 times root 3 is actually 3. And then what we can do is we can say, well, awesome, this is the same denominator, and I'm just going to go minus 1 plus 3. So this is a bit of a sneaky ending, but I'm going to show it to you. And then minus 1 plus 3 is 2 over 2 root 3. But 2 over 2 is just 1. And so my final answer is 1 over root 3. You would have got like 6 out of 7 marks if you got down to this step. So don't stress too much if you're not a fraction ninja, although you want to get better at fractions. All I did was I multiplied the top and bottom by root 3 so that the denominators were the same. So that was the key idea that was important, because when you add fractions, you need common denominators. Okay, everyone, we are going to take a break now because we've been working really hard and we need a break. So everyone on your feet, please turn your cameras on and join me in indulging your body for a second with some oxygen and some unwinding time. So let me see your faces. Let me see you getting up and joining me. So we're going to start with some breaths in and breaths out. So long breath in. One more last big breath. Okay, now trying to loosen up the shoulders because we've probably been hunching over. So just roll those shoulders back. Roll the shoulders forward. And then just shake out your arm nice and loose. Shake out this arm. Shake out this leg. Shake out the other leg. And then let's put our arms out. We're going to gently twist from side to side. And let's see if we can do that. Oh, I can hear lots of clicking happening. Probably a good thing, though. All right. Let us do some jumping jacks. The jumping jacks are just to wake us up. Now, it's been a long day. I'm sure many of you are tired. I'm not doing this just to be silly. Like, there really is something about blood flow that allows us to wake up. So please join me in doing this. This will make the biggest difference to your concentration going into the second half of the lesson. And so let's do it. So in 3, 2, 1, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I am all done. Woo! That is amazing how quickly jumping jacks get your heart rate up. It is remarkable. And before we get back to the second half of our lesson, which I promise I will make a short one today, I would like us to try and make 24 using either you can do the red card or the blue card. See if you can make 24 using these numbers. No one worries, Corsi. I totally understand. Load shedding is part of the South African experience. Just if you missed any bits, I see you really also lost it. Remember, the recording will come out probably by tomorrow, or at least fairly soon. And so just watch those little bits of the recording to fill in any blanks that you may have. Okay, can we make 24 using the red or the blue card? Who feels like they've got the power to do it? Who feels like they've got the power to do it? Okay, so Panga said 7 plus 1 is 8, which I think is a very big hint, because if you use 7 and 1 to get 8, and then Topanga said 4 minus 1 is 3, and I can see where Topanga is going. Because 8 times 3 is 24. And Sapang, the glory of the red card is yours. Can anyone do the blue card? Can anyone make 24 using the blue card? The blue ones, how would I make? I'll just give you a minute and then we must go back to our lesson. But it's always good to let your brain go and do something other than the work. And then when you come back, you feel refreshed. What about 3 plus 2 is 5. No, no, no. 4 minus 2 is 2. 3 minus 2 is 1. No. That's quite a tough one. Okay, I'm not seeing it because I don't look at these before. I just grab them, but I don't know the answer. If anybody can solve that, or let me know. But otherwise, we'll put this at the beginning of our next lesson for a continuation. But I think at least has given us a chance to think about something other than trig. And now our brains are ready to go back to some trig. Okay, what I want you to do is I want you to try and simplify for me number 2. And I also want you to try and simplify number 3. So please try and simplify without a calculator, number 2 and number 3, and then just say 2 done or 3 done when you've done with those. If you are feeling a bit lost, I want to encourage you to ask a question now, because while students are working independently, it's a fantastic time to ask a question if you have one. So I'm just putting that option out there for anyone who has a question or something they just want to clarify sometimes. Otherwise, let's do blue and pink. Ooh, did you get the blue one as well? Okay, it's fun. I'll come back to it at the end of the lesson. You can reveal to me the solution. Hmm. Hmm. Okay, so what do we have for number 2? It's minus tan 60 times minus cos 60. And the negatives cancel out. But so you need to evaluate what that is, whatever that is. If you're feeling generous, put your answer for number 2 in the chat. And these two negatives cancel each other out to give a positive. See if you can do that. That's O. Okay, so number two's answer is root 3 over 2. See if you can do the pink one. Actually, I'm going to redo it down here rather. Okay, this is going to catch a few people. Who can tell me why this becomes 1 plus sine 30? You put it in the chat, or you can raise your hand and just tell me audibly. I want an explanation. How did this become positive? Goodness gracious, what's going on here? Who is willing to share their thinking with us? Negative times a negative is a positive. Tsapang, you're right on the money. And here's why. This becomes minus sine 30, but there was already a minus in front. And so minus a minus gives a positive. Yeah. Okay, so now to finish this off, we need, oh, that's too big. Let me get a smaller. 1 minus the cos of 30. So the cos of 30, I have to be careful here because my O is going to be in a different place and my A is going to be in a different place. So 1 minus the cos of 30 is 1 minus root 3 over 2 times 1 plus the sine of 30 is 1 over 2, 1 over h, yeah, which will be that. And then if I multiply that out, I would get 1 plus a half minus root 3 over 2 minus root 3 over 4. And here's the problem again. It's these common denominators. So you know what? I'm going to make this 4 over 4. I'm going to make this 2 over 4. I'm going to make this 2 root 3 over 4. So notice what I'm doing. And then why am I doing that? Well, I'm not allowed to use a calculator. So all I'm doing is I'm timesing the top and bottom by 4 here, top and bottom by 2 here, top and bottom by 2 there, and then here I don't do anything. So my final answer will be, move that out of the way. 4 plus 2 is 6, and then minus 2 root 3 minus another. So it's going to be 6 minus 3 root 3 over 4. And you could simplify that further, but I think that's fine. Now, again, I'm doing these fancy fractions at the end because you're the S class. But if you had got to here, you would have got 5 out of 6 or 6 out of 7 most of the time. So don't stress too much if you didn't get that last bit. Okay, I want you to now try and simplify this one. Can you simplify and evaluate without a calculator the one in yellow? Can you do that? Oh, sorry, Ruli, I didn't see your message. How did the sign change? Well, let me, while people are working on 4, I'm going to go over what I did to do that. Let me get rid of some of the other stuff. And then I will do a little explanation of how it became negative. So 1 minus cos 30. 1. Now, this becomes, there's a minus. Now, this thing over here, sine of 180 plus 30, actually is minus sine 30. And the reason it is, so I'm just focusing on this bit, is because that is in quadrant number 3, and sine is negative in that quadrant. So it needs to become minus sine 30. But because this is minus a minus, this bracket becomes 1 plus, and then that's where it comes from. So I hope that helps, Rudy. Well, for number 4, what I would do is I would just say 360 plus 360 plus 60. Or, so what some teachers like to do is they actually say this is 720 plus 3 plus 60. Because if you think about how this works, you go 360, another 360 to get 720, and how much more do you need to get to 780? Well, you need to go another 60. So let me just do that. You would write this as cos 720 plus 60 plus sine 360 minus 45 times, now the 420, that's going to be 360 plus 60. So that's how you have to write it out, but you still need to evaluate it for me. So put your final answer in the chat when you're done simplifying this. So I'm just doing the same thing that I did last time, where I multiply it so the denominators are the same. So on the bottom, I'm going to have 2. Now, root 2 times root 3 is actually just root 6. That goes to your knowledge of surds, which we covered earlier in the year. But if you haven't thought about surds, don't be afraid to look at the videos. And that would be 2, and that would just be 1 minus root 6. Okay, I'm going to stop there for today. And I just want you to think about what we've done today. We've looked at reducing trig ratios of very big angles to smaller angles, or using the reduction formula. And the main idea that we used initially was to take the big angle and write it in terms of a formula or a reduction formula that almost has a big piece and a small piece. And what we used initially was we used the angle formulas for the different quadrants. Although what has to happen sometimes, as you saw in this last example, is what happens if you go around more than once? Well, then what you do is you say, well, how many multiples of 360 is it? For example, and it's 2 multiples will give you 720. But you always have the big bit, which gives you the horizontal, and then the small bit. Then we use the cast diagram to reduce the angles to either positive and negative, and then that little bit. And then we use special triangles to evaluate the stuff without a calculator. And then the other skill that came up a couple of times was, if you want to add and subtract fractions, you need to have the same denominator. And so sometimes I was forcing one of the fractions to look different by timesing the top and bottom by the same thing, so that I could then put them together in the end. Okay. Give me as we end today, a score out of 10 in terms of your understanding of the content in this lesson. If naught is like you know nothing of the stuff we've done, and 10 is perfect understanding, where do you feel you are at the moment out of 10? I'd be curious to know, and then I'm going to declare this lesson over for today, because I think we've done enough hard work. Okay. Thank you, Khosi, Tsepang, Zelinda, really for letting me know. That's awesome. In the next lesson, we are going to go on to what's called co-ratio reduction formulas, or co-ratios. And then we're going to start mixing together reduction with co-ratios and normal reduction, and bring it all together, and they'll start to move towards trig equations.